Hey everybody, we are back for the moment. Just last time we had power for about 35 minutes. Funny enough, we had power this morning for about an hour and 10 minutes. You never know, power goes in and out. That's the way it goes for who knows how long. So let's get serious right here. You can see the title of this stream. We pretty much covered everything for 201. Just if you go off of what I said on how to do your outro, going into new future ideas, you should do pretty well. Looks like I moved the camera a tiny bit because you can see the edge of my monitor right there. So, oh no, I think I actually moved the monitors what I did. There we go. Okay. Moved the monitor. So we are good to go. Let's hop into this. Don't want to knock over anything. Let's do this. We'll jump right into this. Here we go. Okay, let's look at some output right here. We're going to talk about association output, and let's go over here and talk about what we need. We need library reg class. So what is library reg class is for 320. So don't worry if you're 201, you can learn some interesting stuff right here. If you're in the chat, feel free to say, hey, MuteBot's on, collecting all the points. What reg class is, think of it like a collection of video games. That's the best way to think about it. Because you can see what's in reg class right here by going to the library, and you can see all these neat things. I think they're neat. You've got different data packages inside of here. You've got different things. In 201, I showed the correlation demo. So I went to core demo yesterday while we were able to stream for a moment and showed the correlation demo, which is something we'll use in 320 also. And we talk about correlation next week. Everything should be good next week. So you can see we're just seeing correlation, then we can see the impact of an outlier and how outliers can drastically impact correlation. So I think this is a much better way to talk about correlation than me drawing them by hands, because you can see the value of correlation and R squared, which is just correlation squared. Then we could put in an outlier, and you can see the outlier drastically impacts the value of correlation. So there's a lot of other things inside of here too. What am I talking about with this? We're talking about reg class, and the reg class has all of these things we can use. And so we load it up. This loads it up so we have access to those things, because when I type in something like associate, it'll then say it's inside the reg class package. There's other packages also, or libraries, excuse me, like the Plotly library, one of my favorites. You won't have this probably, but you can now do things like ggplotly. And notice ggplotly is inside of the library. That's the name of the library it's inside of. And you probably don't have this. To install libraries, so if you don't have reg class, you'd go to install packages, and you'll go here to reg class, and that will install it. So you probably have done this. If not, make sure you install reg class. But these are what the libraries are and the packages are. So you have the reg class library, and you download the package from it. So that's what these are. And now let's get serious with it. Let's do some work with it. We're going to load up data. This loads up data that's kind of natively loaded into R, not loading in like an Excel file or a jump file or a SAS file or a CSV. This is data that's like preloaded into R. So this is like games that are preloaded on your computer. Everything's video games with me. And so we're going to go to survey 11. Notice how this says it's in Plotly. This is in ggplot2, survey 11 right here. This is just explaining what this code does. So this is going to load up survey 11, which is a data frame inside of the reg class package. That's what this does. Just so you can see a different version of this, if we were to go here and type in, we'll bring up the data sets. There we go. If we were to run this right here on wind is a data set inside of the Plotly package. So if I run this, take a look over here on the far side as I clear it off, you'll notice that wind, and I hate that it always does that, it always shows like promise. It means it promises it's there. That's what promise means. It took me like a semester or two to find out, what does promise mean? It says, I promise it's there. And I don't know why it just doesn't show it. So wind is currently in our global environment. That means it's in the brain of R. R knows it exists. Think about where the brain is at. It's right up here where my brain is at. This is the brain of R up here. We don't care to put wind there. We just want to load survey 11. I do want to point this out though, that what you're doing right here is loading pre-existing data that we already have access to. If you wanted to load data that we didn't have access to, you'd probably have to do something like read CSV, or you'd have to do something like read Excel files. So we can read in Excel files using a function called like read Excel. And I mentioned this because many students after this class might say something like, hey, Brian, how do I get data into R? And I'm always like, no, you have to know how to get your data in. If you're going to analyze data, you have to know how to get your data in. So this is preloaded data. Let's put some notes right here. Preloaded data. And this is loads CSV files. And you'd be shocked to know what load read XLS does. It loads in we got to do the sound effect. It loads in XLS files, just mind blown right there. So with all this, we really don't care about these things right here. What we're talking about today is the associate function. Now, the reason we had to do all that is because we needed some data. We needed something like Survey 11 right here so we can work with it. We are live, Mubarak. Good to see you here. We are currently live. I'm doing this so everyone in 320 can see it and have access to this video. So feel free to ask questions. We're going to talk about how the associate function works. We're going to try to do 2 ways of doing it. Right now, the internet lasts for about 30 minutes, and I'm on minute 12 of having power. So minute 12, we got 18 more minutes, hopefully, at least. You never know, it could go out right now. It didn't. So let's look at Survey 11. These are the variables inside of it, and please ask questions if you have them. I might do a lot more talking because, my time's limited today. So notice how we have multiple variables right here, and all I'm looking at is the Survey 11 data frame. We have gender as a factor, height is a factor. Let's go. I mean, height is a numeric variable, which means it's quantitative. So 2 1, categorical, quantitative, quantitative, categorical, categorical, quantitative, categorical, 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 and you can see how many levels there are. So you can see all this information over here giving you a summary of what these variables are. So pretty good summary: quantitative variables, categorical variables, quantitative, quantitative, categorical. Like morning person. Are you a morning person? Yes, no. Even if you pull it out further, you'll start to see some of the variables right there with the responses, no and yes. So we can get a good idea with what we're working with right here. And you know what I'm wondering about right now? Let's go right into some output. Let's ask if somebody being a morning person, we're going to use the way of making our lives easier. We're going to attach Survey 11. What this does is when I type X30 here, X30 will now autocomplete. So when you attach something, it gives you access to these vectors that are right up here. These vectors that are inside of a data frame, I have access to them instantaneously. Usually, you would have to use a $sign to reach them. So I'd have to type X30 here, and that's how I could then reach this vector. But with the attach function, I can instead just type X30, and I have the vector. So the attach takes these vectors here and makes them available at the kind of top level. So attach takes vectors from a data frame. So we're attaching the data frame to the global environment, making those vectors available. Always think of it as a sentence. I am attaching the vectors in this data frame to the global environment so they are available anytime I want to use them. That makes my life a lot easier when I have to type these variable names. The next one's not going to be so crazy. It's going to be X07 GPA. The reason I like this is because of autocomplete. When I type X07, I'm not going to type the remainder .gpa because I could make a typo. I could do lowercase, and this is case sensitive. Now, I did lowercase, but as soon as I hit enter, it's going to correct it. So I don't usually type the whole thing. As soon as I see, which is after 3 letters, the autocomplete kicks in. I see what I want. I just hit enter. Makes my life a lot easier. The next thing I'm going to do right here, because I want this code to work no matter what, I just want to make clear everything I'm doing a new argument by putting a comma. Every time you do a comma, you should think, okay, we're putting in more instructions, a new argument. Here's my formula, my y variable, and my x variable. I'm saying let's try to explain somebody's GPA by them being a morning person. So let's explain someone's GPA by them being a morning person, and that's the equation we're putting in. And then I'm saying now it needs to know that the data this comes from is Survey 11. Notice how the autocomplete kicks in, even though I did 4 letters. We should be pretty good. In your assignments, you will do a seed. I think I said use seed current year. That makes sure the results are replicatable. Sometimes you'll have to do permutations, such as like permutations 5000. I like to do new lines each time. It just makes it easier to read. And you can just see first argument is the equation y tilde x, which is our formula format. Next argument is the data frame we are using. Next is the seed, can be just any random number to replicate the results. And the last argument right here is the permutations, which control how many random permutations we're creating. Just to explain briefly what this does so you can see, when you create such as like 1 random permutation, it got mad about the graphic margin. Here we go. When you create one random permutation, you can see the one box for the permutation down there. Two random permutations, you can see the two random permutations down here. Three random permutations, you can see the three random permutations down here. So we don't want to create just a few random permutations. You can see as we get more and more results down here, random permutations, usually we want to create a bunch of random permutations. You'll notice it takes a lot longer now to create the random permutations. It's taking a good bit of time. So now, give me my random permutations. Wow, it is taking a good bit. Oh, is it asking? No, there we go. It did take a good while to make those random permutations. Lots of results right here. And unfortunately, our results are going to... did it unwrap the screen? No, screen's all wrapped. Okay. So I'm going to change this down to 500 so we don't have as crazy and put the screen about to here. And let's look at GPAs of morning people and non-morning people and look at these results. Okay. This won't take as long, and this is why you could lower your random permutations. Let's go through the output right here at the very top. With the very top of the output, and I know I just wrapped the screen differently, but when you have the screen small, the box is down here, it's hard to read. So now let's read it. Okay. Let's start at the very top of the output. What do we have? We have side-by-side box plots. Side-by-side box plots are a categorical X and a quantitative Y. We should know this instantaneously. I don't see that big of differences because I see here the median for both is about the same and the mean for both is about the same. We do see some outliers, and this is a little bit of left skew, which is much more clear to see in the histogram. The histogram shows an outlier down here, which is this individual here, and we see the left skew because it's pulled a little bit to the left. And we see that also here, a little bit of bimodality too. I mean, it's kind of just a higher area and then goes down. But one thing we want to look at most importantly is the QQ plots for normality. These go by QQ plots, normal quantile plots, and normal probability plots. So I know I just said three names right here, but a lot of times in our class, we'll call these QQ plots for quantile plots, not like QQ strain of no outliers, even though they are two quantitative things. But the point of a QQ, or normal quantile plot, or in Stats 1, normal probability plot, is to check to see if things are normal. So this red line down the center indicates normality, and if our points follow it, they're normal, but if they deviate, they're not normal. And I'm really seeing some deviations here, especially on this top side right here. If you look, this does follow normal until you get over here, and that's why this is going a little crazy. It's kind of normal-ish. I mean, you got that outlier down there, which should... Surprised that's not... Oh, it didn't extend. Ooh, should extend all the way to that. We see a jump right there. And just to make it even more clear, because I'm going to make a QQ plot of that, we should have our QQ function right here. And let's go grab X07 GPA. We can't make that. And there's that outlier. Or really, it should graph all the way down there to that. Oh, no. I was wrong. That is that person. There they are right there. This is the observed value on the left side. And this is the whole variable right here. We've got this extreme outlier down to here, and this is what we would expect. This is what we observe, and they are pretty far away from the expected value on the normal curve. So I see a pretty strong deviation in the overall variable, and looking at our graphic here. And so we do have, it's just, I think the no box is covering. I think they are over here. They'd be down here. That's really sad. I hate that that box is covering it. Can I? That really bugs me. If you increase your output sizes, you can change how this works. I just really want to show that individual. Nope. There we go. There we go. I knew they should be there. I kept looking for that individual, and there they are right there. Just very important to me. You know, when we're talking about this person here, we should be able to trace down and see them, and that's their value over there on the left. It didn't make sense to me that I couldn't find this outlier that deviated from the normal curve. I just want to make sure, like, the graphic I'm seeing makes sense. This person's right there. They're deviating. We see deviations up here. And really, this plot is where you want to look to see whether or not it's normal. And this does not look normal to me. Since it does not look normal, that means we need to analyze the medians. Now, these are not the values of the medians. These are all the random permutations. This is our discrepancy with the medians. And what do we have from this? We have our p-value. Let's go ahead and grab the snipping tool and show how to get the p-value. Very important when we see a graphic like this, we understand what we have. We're going to bring this graphic over here to Word. which crashed on us last time. 1,000 crashes. And let's clean it up just a little bit here. Come back to the screen. And let's talk about this graphic. It'll drive me nuts. I'm big on things have to look good. Hopefully we can do both outputs. We will see how the internet goes. Okay. So what do we have right here? It's important we know exactly what this output's showing us. The red line is our result. So this is our result. Hey, what's up, Mark? When I run the code and the condition tail just shows the graph under the code directly, is that okay? Yep. Should be good. You can send me it if you want me to look at it. I'll try to look at it. So send me, it should be good. Just look at how it knits. You want to look at how it knits. There's the p-value. So if I'm to estimate this p-value, I'm going to say it's about 35%. I say 0.354. 0.354, that's a fun number. So here's our result. That's our observed discrepancy, which is going to be about our observed discrepancy is about 0.6, and our p-value is about 0.354. I'm going to be close on the observed discrepancy. And so let's take a look over here. Let's rerun the results so it doesn't wrap the screen. And I said 0.6 and 0.354. The answer is, and I swear I didn't cheat, the discrepancy is 0.6, and the p-value is very close to 0.354, or whatever I said, 0.354. Yep. So pretty good estimates. You don't have to estimate like that, but it's very important you kind of understand where these are coming from. As in, let me put the graphic back on the screen right here. I think we can show the Word document at the same time. Put this. So this p-value right here of 0.414 is the shaded 0.414 is the shaded area to the right of our observed result. This discrepancy right here at 0.6 is our observed discrepancy between 3.3 and 3.3. Now there's a zero discrepancy, but the way it does the test is it looks at certain quantiles, and we don't have to know the exact way it's doing it, but it's looking at the quantiles and it's figuring out that the median has this sort of deviation via multiple ways of, we're not going to calculate it, is the good news. You can see that the means have a little bit of a discrepancy, very, very small discrepancy. But what's the biggest thing you notice right here, Mubarak or anybody, and I'll probably answer it in 10 seconds because I don't know how long the internet will last, is that this difference is not statistically significant. And we'll be talking about this more on the next assignment. The difference is not statistically significant, and we're confident that it's not statistically significant. So we're estimating the p-value, and I'm 95% confident the true p-value for this test is contained in the interval 0.37 to 0.459, and that does not include 0.05. So there's good evidence that this is not statistically significant. So it's not statistically significant, and we're confident it's not statistically significant. And so that should analyze this output pretty fully. We have sample sizes here. These are how many people were not morning people, how many people were morning people. Here's the average GPA of not morning people, the average GPA of morning people, the discrepancy, which is the F statistics. Here, we'll throw some 50 points out there. I'm so sorry. Let's throw some 50 points. You got it, Robbie. So this F statistic, we do need to talk about this briefly right here. So the F statistic is, let's talk about it with the word pad. Okay. I think the only thing we need to else mention this output. Okay, so the F statistic, super important talk right here. When you're doing an F statistic, it's the following. It's the observed over the expected. That F statistic right there is the observed over the expected. So it's the amount of variation we observe over what we would have expected. So what is an F that we would expect to see? So it's the observed over the expected. So if you think about it, if I say the F we expect to see, it would be this. Like if we observe what we expect, does that make sense? We're taking what we observe and we're saying, okay, here, what we observe is what we expect. So what we observe is what we expect. So observe is now going to be, we're going to observe what we expect. What do I mean by this? Like, let's say I expect a car to cost